Hello, welcome to week 5 of SPSS, the SPSS workshop. So we're going to be doing multiple linear regressions this week, and linear regressions is a good way of determining which predictors can predict an outcome or the effect. And the effect or outcome in this case is going to be our dependent variable, and our predictors are going to be the independent variables. And we're going to have various independent variables that you hypothesize might predict the outcome. So if you hear sawing, I apologize. Right outside my office window, somebody's sawing. So hopefully it won't pick up too much of that. All right, let's get going. So this is what you have on your screen when you open up the data set for this week. Okay, so let's go ahead and plunge into multiple linear regression. So let's go up here to Analyze. Okay, go to Regression, Linear. Okay, and you have this. Okay, so I'm going to put these back because I already did them. So let me put them back so we can repeat these. Okay, so all right, so what we have in your dependent variable is job performance, promotions, okay? Job promotions, you put them in the dependent. All right, so that you want to look at the variables that might predict job promotions. Okay, so the three variables that we want to look at are number of sick days, okay, years of service, and monthly cases. Okay, so again, you're hypothesizing that these are going to be predictors of how well people are promoted. And when you run the linear regression, the reason it's called linear is if you put them all on a straight line and you draw a line between them, you want to see how close the dots on the scattered dot matrix cluster around that one line. So that should that can tell you which one of these is a strong predictor, and certainly which one of these is a better predictor than the others. Okay, so let's go to okay. All right, so we have this. So for your analysis, cut and paste these tables onto Word and interpret them. So for your homework assignment, the first one is to go over here to the ANOVA. We haven't covered the ANOVA yet, but we will. But suffice it to say that in this one, the ANOVA looks at a significant relationship between the variables and between the dependent and the independent variables, but it doesn't tell you exactly where the significance is. So you start off with the ANOVA because look at where my arrow is. If that number is not statistic, the rest of the information, the rest of the data that comes up is really irrelevant. So you might as well stop right there. So we'll go into more detail later when we do the ANOVA and MANOVA. But for now, suffice it to say that if that number that I'm pointing at right there shows that there's no significant relationship between the dependent and independent variables, you can stop. So that number has to be less than 0.05. Indeed it is. So that's your interpretation of the ANOVA. So let's go down here to the coefficients. So the dependent variable, or the thing that we're predicting, the effect, is job promotions. So let's ignore constant. Let's look at sick days, years of service, monthly cases. So which one of those is the strongest predictor, and then second to the strongest, and so far, and so on and so forth. So let's look at the B value. Okay, so the B value, the higher the number, the more the stronger the prediction is. Okay, so I'm not going to give you the answer, but I want you to look at it and interpret it and write up your own answer. But basically, the higher the number here, the higher the fact that it's predicting the outcome. The thing is with the B is that they're not standardized because one might be a different scale than the other. So you're kind of comparing apples and oranges here. All right, so that's valuable, but most important is the beta. That gives you the strength of the relationship, and it's standardized. Okay, the coefficient is standardized as if they each was using the same scale. So I can look at both of them, see which one has a higher number, and then also this gives you a strength. Look at this as a strength because it's a standardized coefficient. So the closer you are to 1, the better it is, or the stronger it is. Now, I'm going to leave this for you to interpret, but notice that this has a negative number. Okay? Look at sick days. Would you expect that to be a negative number? Because you're not saying how many well days they had, how many good days did they go to work and be successful. You're looking at sick days. So ask yourself, are sick days a good thing or a bad thing? And if it's a bad thing, would you expect that the higher the number of sick days you have, it's less of a predictor? Well, no, let me put it this way. It's still a good predictor, but if you have high number of sick days, the likelihood of you being promoted goes down. So as one number goes up, the other number goes down. So look at it in terms of that, in terms of the negative number. So what I want you to do also is resist the temptation to say that negative 0.744 is the lowest of the 3 numbers. Okay, let me say that again. Resist the temptation to assume that negative 0.744 is the lowest of these 3 numbers, because it's kind of supposed to be negative. Okay, and that's enough of a hint to give you. Okay, so also you want to report the B, you want to report the beta. Tell me which one of these is the strongest. Okay, and which one of these is the strongest, but with the caveat that they might be different scales. These, tell me which one's strongest, with the understanding that these have a better, they're comparing apples to apples. They're using a standardized coefficient. I would go with this. And then this is extremely important, okay? Because these numbers have to also be less than 0.05, okay? If it's not significant, it doesn't matter. There needs to be a significant prediction, level of prediction, and then you can report the rest. So ask yourself, is this less than 0.05? Is this less than 0.05? Is this less than 0.05? It has to be less in order to be significant. Okay, so that should do it, and that should take you through questions 1 and 2. Now, as far as actually drawing out the equation, I'll leave that up to you. Let's leave that as optional, because I think there's enough work here that we don't always have to sketch out the equation. I want you to give me these answers, produce these tables, and then interpret the output. And again, the interpretation I want is the ANOVA, significant, yes or no. What does the B and what does the beta value tell you? And are they statistically significant? That's pretty much it. If you want to take a stab at writing out the equation, that's fine. I won't dock you if you don't. Okay, that can be optional. Okay, let me stop, and then I'll do a separate recording for the other two. Okay, have a good evening, and good luck with this.